In this video, we will discuss the basics of hypothesis testing. Hypothesis testing is also known as significance testing. A significance test is a formal procedure for comparing observed data to a hypothesis whose truth we want to assess. The basic reasoning behind significance testing is that an outcome or sample that is very unlikely if a claim were true is good evidence that the claim is not true. An important caveat to significance testing is that these tests look for evidence that a claim is false. They do not establish that a claim is true. There are 5 basic components to any hypothesis test. There is the null hypothesis, denoted by H sub 0. This is the statement about the population that is being tested. There's the alternate hypothesis, H sub A. This is the statement that we suspect is true. The test statistic is the value we've measured from our sample. The p-value is the probability, assuming the null hypothesis is true, that we would get a test statistic as extreme or more extreme than what we observed. Finally, we have a significance level denoted by alpha. This is the value we've decided in advance to accept as our measure of very unlikely. Now that we know the basic components of hypothesis testing, let's consider the procedure for conducting such tests. First, state both the null hypothesis and the alternate hypothesis. Then calculate the test statistic from the sample. We'll use technology to compute the p-value for the observed statistic and compare the calculated p-value to the significance level alpha. Then we make our decision. If p is less than or equal to alpha, reject the null hypothesis in favor of the alternate hypothesis. If p is greater than alpha, fail to reject the null hypothesis. In no case do we accept the null hypothesis. The test is not set up to accept the truth of anything. Finally, we summarize the results. The next video will provide examples utilizing this procedure. First, let's consider how we know which test to use when they're all available given our technology. Let's consider the most basic tests. A z-test for a mean will test for evidence against a population mean being a specified value. Z-tests require that the population standard deviation sigma is known. Thus, we won't often use this test in practice. A t-test for mean tests for the mean of a population and is used when sigma is unknown. In this case, we approximate sigma by little s. A z-test for a proportion tests for a population proportion using the binomial distribution. The parameter sigma is always known in a binomial distribution. A two-sample t-test for means compares means of two populations, and a two-sample z-test for proportions compares proportions from two populations. Basically, we use t-tests for means and z-tests for proportions. The next video will use these ideas to illustrate several different examples.